Our next speaker is Sourabh Lal. He is a master's student at EPFL and he's studying computer science and is specializing in information systems. He is a founder of EPFL's student hackathon, the LauzHack, and currently he is a GitHub Campus Expert, which is a role that enables him to help empower student developers at EPFL. During this workshop, Sourabh will introduce some of Git and GitHub's slightly more advanced features.
Okay. Thank you for the introduction and for having me here. So like mentioned, I'm going to be talking some of the more advanced features of GitHub and Git. So I'm assuming that you already have used it at some point, maybe know how to make some commits. And I'll be focusing more on how Git can be used for collaboration and also how to deal with things when things go wrong, basically. As mentioned, I'm a campus expert, which it means that I don't actually work for GitHub, but GitHub actually helps me help the student community, and in particular, I'm the campus expert at EPFL. And so first I'll talk about why Git. So we've all been so there are always situations when Git's really used for version control. So in the past, many times when I didn't know Git, you'd create a file, then you make another version. And so maybe, I don't know, you'll have a name which is like final, extremely final version or something. And it's cases like this when Git is a very useful tool to have. So in particular, the three main advantages are that you can know the history of a file. So what changes you made, who made them, when they occurred. You can back up your files and have different versions of code. So maybe if you make some change, you can revert back to a previous version. And finally, you can have multiple contributors who make their own additions, changes to the files, and you can be able to track who did it and be able to work in a team even though you're working separately. So just to go through the three main things. The first thing we're going to talk about is some good practices. So how to use branches, moving around between different branches of your code, making merges, and dealing with merge conflicts in the process. When things are broken, some really useful tools such as using reset, amend, rebase, and reflog. And finally, in the end, I'll talk about something which is a bit more GitHub specific, which is using the GitHub flow, which is using creating issues, making pull requests in order to be able to collaborate. So on to the first part, which is Git good. So in this, I'm going to be talking about branches first. So the idea behind branches is that you can work on different versions of the same code at the same time. And so essentially, when you're developing a project, you're not necessarily going in a linear fashion where you're making some small additions and every time the new addition is made, it's in a straight line. Rather, you can have like two different versions at the same time, where maybe a simple example would be that if you are working on deploying, let's say, a website which has some information, you have the version which is live, which anyone can access on the website, and the other one which you're still adding new features to, and you don't want this to be public, so you can maintain these different versions of the code. And so for this, you use a tool called branching. And so how do we do this? So yeah, other examples are in addition, like if you have a bug fix or if you have a different release. And so how this works is that suppose you are working on you got a particular commit, and then you make a new branch where you add new features, and another commit, another change that comes in has another set of features that comes up. And the idea behind this is that you can have these separate versions where making changes to one does not affect the other, and you do not have any issues when two different people are working on two different things, for example. And so how we do this is, so there's a simple command which is git branch, which essentially is used for listing branches and also for creating them. So if you just use git branch, it will basically give you the list of branches you have in your repository. And I'll be doing like a demo afterwards in which I show how all these commands work. So I'm just doing an overview now. And then by default, you have the master branch. And when you might make a new branch, you can essentially use the same command and just add a name for the new branch you're trying to create. And the next, essentially what this does is it takes the version of code you have at the current moment on your master and makes a new version of it on the separate branch. So essentially, you're creating a copy of the current code base before you make your new changes. And then you have this command called git checkout. So checkout is a useful command. Essentially, it allows you to pick a version of the code you want to work on. So a way you can think about this is like, suppose you're working on your master. When you check out the code, it essentially changes the files you have on your system to the files in the other branch. So what you would notice is that everything changes completely when you check out from one branch to another, and that's to be expected. And like a simple example here is that when we use git branch, we can see that there's a development and master branch, and when we check out develop, it loads all the files for the development branch.
What was the check mark?
That's basically it's some internal test that I had. It's nothing to do with Git. It's just something in my system. And essentially, when you're checking out, you can specify two different things. So this is where a reference is useful. So you can either give a branch name, which is a different branch you want to work on, and checkout is also useful if you want to change any version of code. So it can even be on the same branch when you want to go to a previous version. So you'll have like an ID for each commit you make, and if you just give the ID, it'll actually shift back to that version of the code. All right, as I mentioned, it'll change the files in your folder. And basically the steps are essentially you make a new branch, you check out the new branch, and then you make the new commits you want to work on in the current feature you're developing. So then the next idea is merging. So you've got your different branches, and let's say you made a new branch, you developed a new feature, and now you want to bring it back into the master that everyone has access to. And so merge essentially allows you to integrate your changes into the main code base. And the way this works is that you're working on this second branch, and essentially you bring it back in here. And for this, the command used is called git merge, where essentially you provide a target, which is the branch you've been working on. So essentially you would be working on you go on the master branch, and then you say you want to merge in the development branch, and then it would bring that in. And there are two versions of this. So one can be used if you're making a new commit, or the other is to fast forward. So essentially this means that, so when you're making a new commit, that means that if you've made a new branch, you've worked on it, and you want to merge it back in. And fast forward means maybe someone else has worked on some changes, and you want to bring your current code up to the latest version. So this is also where fast merge would be used. Essentially, instead of specifying your own branch, you specify the branch that someone else worked on, in this case. Right. And so sometimes you have these merge conflicts. And so the idea is that this is, I think, the most, especially when you're new to using Git, this is the most annoying thing that could happen. Because at first it doesn't make any sense what's going wrong, and essentially everything stops working. And essentially what you have to look for in the code here is that what Git tries to do is that when you try and merge code together, it'll pick out the new changes and bring it in automatically. But sometimes maybe two different people have worked on the exact same line of code. And in this case, Git, it knows where the changes happened, but it doesn't know which is the latest version, because both people have worked on it at the same time. And this only occurs when both of them have been, both branches have been created at the same point before these new changes were made. And so it doesn't know, maybe let's say I worked on it and one of you worked on it, and we worked on it separately. So even though maybe it has a timestamp where maybe mine was later, but I've not seen what you did, and maybe yours is better. And so here Git allows you to actually manually pick which change to keep, or even combine it yourself and make like a third version. And the way it does this is it actually, everywhere in the code where it sees a conflict, you actually have to go into the file, and it'll have some sort of marking like this. So essentially when it's, the first line specifies head, which refers to the current status, pointed to the current status within the master branch that you're working on. And the conflict is, let's say, in this case, conflict refers to the branch name I was using. So it's showing the change that was made in the branch that you're merging in. And you can see that, okay, there's a slight difference in text. So the idea is that you'd replace this entire section of text in your file with the correct version, essentially. And I'll be showing this as a demo in a short while. Right here, so essentially you've removed the markings, and you've made the latest the correct version of the text. And now when you commit this change, after combining this manually, you commit this, and everything will work the way it should. And just a quick step-by-step, so it's a bit of a summary. So when you make a commit a new branch, essentially when you merge this in, you have to fix the conflict manually, and then you add the file and commit it after making these changes. And in case you're in a situation where you feel that the merging that you're doing is causing too many problems, you can use the reset command, which essentially shifts back your code to the version before you tried merging, and all the merge conflicts will disappear, and you won't have it, like, you'll essentially be resetting it back to the version of code before you did the reset. Okay, and Okay, so now I'm going to be talking about what happens when, so this is a simple case where you've got a merge conflict, but what happens when everything is broken? There's some more powerful tools that Git has. So the first one I would say is like the most common thing which people want to do is make a change to the last commit you made without having to create a new commit. And so in this case, there's a command called the git commit amend. Essentially what this lets you do is either change the commit message to something more meaningful or actually make modifications in the last file that you've committed. And the idea behind this is that you're actually creating a new commit, but what it does is it replaces the previous one rather than adding a new one on. And this is quite useful because I'm sure it's been discussed before that when you are working in a team, you don't want to have too many commits about like small changes that you're doing. Rather, maybe you want something more meaningful, or maybe you forgot to commit something in the previous commit. And so having a readable commit history always makes it much easier to collaborate, and even for you to go back and find things you worked on. And so this is where the commit amend command is quite useful. The second one is rebase. So the idea here is that suppose you've worked on a new feature in a branch, and now when you want to merge it back in, you want the changes that someone else has worked on to also be included in your version of the code. And what this actually does is it takes the code that you've worked on. So in this case, over here, the two versions of code are the same, and you make a new branch and you added those two features. And in the meanwhile, someone has added these two features as well. And when you merge this in, what you're essentially doing is that you want these two features to be added in after these other changes have been made to the main branch. And this is where git rebase is a useful command. And in particular, there's a slightly more useful version of it, which is the interactive rebase. And this gives you a lot more control over how you want to make the changes to commits. So essentially with rebase, what you can do is you can specify where your new changes are being added in. Whereas with rebase, you can actually make modifications to all the previous commits. So there's many different commands. So you can drop certain commits that you don't want to be, that shouldn't be included anymore. You can maybe reword them. You can merge several commits into one. And I'll be showing a nice demo for this as well. And finally, there's git reflog, which is essentially the ultimate safety net in Git. So many times when you're working on something, perhaps you rebase and you delete a commit, or maybe you've lost some files. Git actually keeps everything that you've worked on. And what you can do with git reflog is actually see every single version of your code that you had at any point after starting the Git repository. So the idea is here, I've got a simple example here where the first thing someone did is checked out the code from the 2.2 branch, and then they checked out the branch from master, and at some point they reset their code so it goes back over here. And essentially you lose the two changes, the checkout that you did. So you want to go back. And what git reflog does is it has a list of all the commands you've used so far and the IDs, which means you can just use git reset and enter the ID of whichever commit you want to go back to, and it'll take your code version back to that exact same point. And now I'm going to do a quick demo of a git merge and also the tools that I have used. All right. Just one quick, is everything readable here, or should I increase the size? Do you think it's okay? At the back especially? So small. Okay. Sorry. Okay, so what I did is I have this really simple repository. It's just got one file, readme.md. The contents are basically just a little bit of text that I've added in, just talking about what I'm doing in this workshop today. And yeah. Sorry. Okay. So it's just got some text here. And what I want to see is what's the status of my repository. So if I use git log, I can see that these are the 7 commits I made. So I added some text in, I went back and edited it, and so on. And now if we look at this repository, in the file, so the first line is hello world. And let's say we don't want to say hello to the whole world. Let's say only to Ticino. And so someone decides to make a new branch for making this change. So the idea is, okay, so first I check our branches. We only have the master branch. And so what we're going to do is we're going to create a new branch. Let's call it Ticino. And we now need to check out this branch so that we shift our files to this new branch, so that whatever changes we make are applied to the branch and not to master. And so we're going to do this. And now we're on this new branch that we created. And so suppose we want to make this change to this file. So we're going to say, OK, so I've made this change. And if we look at our git status, we've seen the README has been modified. And so I'm going to commit this. I'm going to add this first. Commit it. And so we've got our change. Now, suppose in the meanwhile, someone else, so in this case, I'm just going to be working directly here, but we can assume that someone else is also working on the same repository. And so let's say we go back to our master branch. And now if we look at the file, it still has hello world, whereas in the Ticino branch, it's changed. And now let's say someone else decides he wants to change this as well. And so we make another branch, which is, I don't know, Ticino 2. And over here, we're going to check this out. And over here, we're going to do another change. And let's say, OK. So now what we can see is that this version of our file is different. And now what we want to do is we want to be able to, we've got these two different branches where we've made the same, we've changed the same line, and we're going to try and merge these together. So first, I'm just going to commit this, add README. And so now we're going to shift back to our master branch, which still has hello world. And the first thing we're going to do is we're going to try and merge in the first change we made. So if we use git merge, and OK. And what it's done is essentially it has picked up the change that we made. And now when we're currently on the master branch, and now if we look at the contents of the file, we can say it's changed it from hello world to hello Ticino. And now at this point, if I try and make the change from my second branch, we're going to see that there is a merge conflict. And in this case, if I open up the file, what you'll see is it's made the same change where the original version was hello Ticino, and now this new change we're trying to do is changing this value. And so what we're going to do to fix this is we're going to open our file, get rid of the markers, and now we have to decide which version we want. And suppose we decide we just want to do this. There. And now if we look at this, we have to add, if we check here, you can see that it's been, it says both modified rather than just modified. Essentially, this means that the changes have come from different sources, and we're currently in the process of a merge. And so what we're going to do is just going to add this file and commit it. And now, essentially, it's going to create a new commit, which is a merge commit, which combines the changes from the two different branches that we worked on. And now, if we look at our list of commits, we can see that both the commits that were made on the other branches have been added in. And then there's a third commit which was created, which combined the two changes. And essentially, the idea is this is a really simple example where there's only one change. But essentially, all merge conflicts come down to exactly this, where you just have to go through the file and find the two different versions of the code, and essentially figure out which one is a part that you need to keep and which one is not. And so now I'm going to, looking at this, I'm going to say that, OK, suppose I want to undo these changes I just did. So I want to go back to the version before when it was just hello world. I don't want to have any of these changes. So for this is actually a very simple command, which is the git reset. So essentially, using git reset hard is not recommended because generally you lose a lot of work that you've done until now. Essentially, with git reflog, it's possible to recover what you worked on, but generally you have to be a bit careful when using reset hard that you're sure that you know what you're doing. But essentially, if I just give the ID of the last commit I want to go back to, I can reset my code, and you can see that it's shifted back to the last commit, which has added the conclusion. And now if I just do the log, you can see the changes have disappeared. And if I open the file I was working on, it's shifted back to hello world. And now if let's say at this point I decide that, okay, for this text I've got too many commits, I want to maybe reduce them. And so I can try and do git rebase. So essentially I'm going to use the interactive version. In this, what I have to specify is how many commits I want to go back for this rebase. So head is essentially a pointer to the current state of your repository, so the latest ID that you're working on. Like we saw a bit up there where it says head is now at 5811df. So that basically is a pointer to what the current state of the repository is. So essentially you just have to tell it how many commits back it has to go. So in this case, I want to go back 6 commits. So I'll do head ~6. And it opens up this editor. So here I have the commands that I want to use for each of these commits and the list of the 6 commits that I'm editing. And so essentially what it's going to do is I'm going to set a command for each of these commits, and it's going to go through them one by one and apply the changes that I've asked it to make. So suppose I decide that, okay, I want to reword this first commit, and all the others I want them to be combined into one commit. So I'm going to squash them in. So I'm going to change this. And so there are all these different changes. You can even make an edit to the commit and so on. But in this case, I'll just do the simple example where I'm just combining it all into one. And so I want to make these changes. And so now the first thing it's asking me is that I had asked to reword my first commit. So it's basically asking me to change the commit message. So I'm going to set it to, rather than having the intro, since I want everything as part of this, I'm going to say, I don't know, create demo. This is the new text that I have. Save it. And now it's showing a preview of the squash it's doing, where it's combining all 6 commits, and it's showing the list of the 6 commit messages that were there. And this looks OK. So I'm going to save it. And what we can see is that it says that it's successfully rebased. And now if I open my log, I can see I just have these 2 commits. And everything's at the latest version. There's been no changes. All the changes I made in these small commits are all over there in the file. And I've just combined all the commits into one. OK, so the next thing I'm going to show you is reflog, which is the safety net. So essentially, this is a really simple command where there's nothing I have to specify. And here what I can see is all the commands I've used so far since I created the repository are all here. So from the initially creating the repository, making all the additions, all the changes, everything, even after the rebase, I can move back. And so suppose I decide that I want to go back to the place where I've not combined all my commits together. Normally, this is something that would not really be retrievable, because once you've combined the commits, it's not that easy to find them. But with reflog, essentially, I can just pick that. Let's say I want to move back to, let's pick here. Yeah. So I've got this commit, and so I'm going to say git reset hard. And now if I look at my list of commits, all of them are back. I've undid all the changes. Technically, I've not undone them. I've basically just reapplied these changes in the opposite order. And so if I look at reflog, I'll see at the top the latest command is the reset I just did. So essentially with reflog, you can basically be able to undo and go back to any version of the code you were at before. And so, OK, so this was just a quick demo showing the different commands I explained. And yes. Yeah.
So the reset hard, you cannot see it here, right?
Yes, you can. So I just did a reset hard right now. And so it's the one at the top, the very first line.
Any the commits where you change from Eliza to Ticino and stuff?
Yes, it's all there. So essentially, if you look here, So those commits are over here. So essentially, if I enter in the ID for those commits, I can go back to that. I can actually show that right now. So suppose I want to move to this version. Let's say this version. So I can use git reset. And now if I look at the code, so it's changed back to the changes I made. So essentially with reflog, you can get the IDs of all the versions that your code's ever been at and go back to it. Yeah.
So what if you pushed the changes before, then you mess around, you do hard reset,
right.
and you push again, will there be a problem?
So that's actually the main reason why reset hard should only be used when it's really necessary. So essentially, when you're working locally and having these different versions of code, you can essentially do anything you want, and there'll be no repercussions to it. But the only concern is that when you've pushed your changes, the only thing is if other people are working on the same code, you could potentially break what they're working on by changing the commit history. And essentially, there's a way. So essentially, when you're pushing, you have to add a new command, which is the force command. So essentially, you force push. And what that does is essentially, it changes everything. And normally, it's something you're not supposed to do. It's only like, I would only suggest doing it if you're working on your own and not collaborating with anyone, because it breaks everything for everyone else. Generally, it's a lot more complex when you're working in a team in that sense. And so these tools are more for, one, if you're working alone, then it's okay. And second, if it's something that's absolutely necessary that, I don't know, maybe there'll be like some serious problems if you don't make a change or something.
But so the other guy who's working, he has a commit tree locally, and
right.
he pulls down the latest
right.
version of the repo. Then wouldn't he have to just merge his current commit somehow into this? Or would it just be overwritten by doing this?
So it's
his local history or whatever, will that be overwritten at that point?
No, it won't be overwritten, but essentially there'll be a lot of conflicts that have to be fixed. Yeah. So in
I mean, can you even merge that in a way? Because in a way you also have a completely different history, right?
So the idea is that essentially, so it gets a bit complicated. Even like I have to say that sometimes I refer to the documentation when I'm doing this. I don't know completely off the top of my head, but essentially what you would have is that when you've changed your local history, there has to be like some common point in the past, which is still the same, and so that could be used when you're trying to essentially figure out where the changes are coming from. But the idea is that essentially what would end up happening is that you would be working on a separate branch when you're doing this, rather than working directly on a master and just pushing all this. So what would happen is that when this other branch is added in, what I would do in this case is the other person would then have to rebase these changes onto his code, rather than actually just combining them with a merge on the master. So right now I'm working on the master just because it's easier to demo, but in general in this case, I would not. Yeah. Right.
Maybe as a recommendation, never use force unless you know exactly what you do.
Yeah.
That's like a good rule of thumb in this game.
Right.
But if somebody force push, you can force pull it if you just want to blindly take it over.
Okay.
Yeah.
That works as well.
Right.
Up the force, more force.
Right. It's
Can you use the word? Because I actually learned that very recently. The safe version of git reset hard.
So yeah, there's
Revert.
git revert.
Do you know that?
I am not that familiar with it, no. But it's yeah.
I think it's like a safe version of git reset hard. So instead of so you go back to the previous version,
Right.
but you essentially create a new commit. Going back to that version.
Okay. I've not actually used that before.
But
But good to know. Yeah. Right. Any questions? Or I can move to the next part. No. Okay. Okay, so yeah, there's also, when I send the link, there'll be a cheat sheet which has a list of all the different commands. So even if you don't remember everything I've talked about, or there are other commands which I haven't talked about, they'll all be in this cheat sheet. So I'm going to talk about GitHub Flow, which is essentially, so every version control has some variant of this at this point, but essentially with GitHub, it's generally the one I've used a lot more, and it's got a really simple technique, which is, it's essentially a way to collaborate on projects. And for this, what I'm going to do is I'm going to briefly explain it, and then there's like a more interactive exercise that we can do, where you can even try this out right now. So the idea behind this is, I'll start with this video, which briefly introduces with an example what pull requests essentially are and branches. Yeah.
Is it with the sound?
Yes, it should be working.
No, I turned the sound down.
Okay.
Chaos of all these copies can be transferred.
Okay.
Most people understand that open source software is software copied for free. What's less understood is how the potential chaos of all these copies can be transformed into a collaborative whole. Let's break down how open source works, using a family cookie recipe as a metaphor we can all relate to. Just like code, all recipes start by somebody writing the original version. In this case, Grandma May has developed a delicious cookie recipe. She shares it with her family, telling them they can use her recipe as long as they follow her rules. In Grandma May's case, anyone who bakes cookies with her recipe has to credit her as the author. And if they make changes to her recipe, she has to be allowed to use those changes in future versions of the recipe. The same thing happens when someone writes and publishes an original version of open source software. They put rules called licenses in place so that others can use and change the code they've written as long as they follow the author's license. Grandma May's recipe provides her family with a place to start that they can customize to their own liking. Aunt Maria decided to add chocolate chips to her batch of cookies. In software, this departure from the original code is called a branch. Aunt Maria's change was such a great success with everyone who tasted the cookies that she asked Grandma May to add chocolate chips to her original recipe. At this point, Grandma May needs to begin acting as a maintainer, looking after the integrity of the original recipe and deciding which changes she will incorporate. In this case, Grandma May agreed that the chocolate chips were a good addition, and so from then on, Grandma May's recipe included chocolate chips. Aunt Maria is now a contributor because she has contributed something to the recipe. In open source software development, this process of incorporating a change or patch into the original code is called upstreaming because it's flowing back to the original source. If the original brand of chocolate chips becomes unavailable, Grandma May is responsible for updating the upstream chocolate chip patch with a new brand because she accepted the patch. The benefits of incorporating your changes into the original recipe are pretty amazing, leading to the popular open source motto, upstream early and often. The sooner you upstream, the sooner the community can back you up, not only by maintaining the recipe, but also by testing it in as many configurations as there are community members using it. Uncle Miles went out on a limb and added peanut butter and nuts to his batch of cookies. His wife and friends all love peanut butter, so they thought his additions greatly improved the original recipe. But when Uncle Miles tried to upstream his nutty changes, Grandma May, who detests peanut butter, refused to add peanut butter and nuts to her recipe. Uncle Miles resolved to move on with his version of the recipe with no plans of merging the two again at any point. In open source software development, a permanent split like this is called a fork. Grandma May's recipe is getting better all the time as people continue to contribute. Her family gets to learn from and enjoy the latest and newest cookie recipes as they are created. As Grandma May's family grows and her recipe is shared outside the family, more and more people will become contributors. As you can imagine, things could get pretty complicated for Grandma May as the maintainer of the original recipe with more contributors. The same is true for open source software. More contributors and more versions of code make it essential that we have a way of collaborating on changes. This is why we need the structure, common language, and roles we just talked about with our recipe example. Now let's recap really quickly. Someone writes an original version of the open source software. They set rules around how it can be used and changed, called licenses. This gives contributors a starting point to then branch out from and make changes or patches. Some request their changes to be upstreamed to merge their new version with the original version. If the maintainer decides to incorporate the change, it becomes part of the main branch and will be maintained by the community even if the contributor stops being involved in the project. Sometimes, software is taken in a direction that we know will not be incorporated back into the original version. This kind of permanent split is called a fork. Open source has the potential to be complicated because it's created by communities of people. But these ways of working manage those communities, making it possible to benefit from new versions from an authoritative source, the maintainer. Actual products based on open source can be made up of dozens, even hundreds of recipes like Grandma May's, which is why having a disciplined way of managing change is so important. In open source, the possibilities are endless, but we need the rules and roles to keep things organized.
Okay, so essentially this video went a bit beyond what I was I'm covering today, but essentially the main idea is that GitHub can be used for working on an open source but collaborating, and for this it uses something they call the GitHub flow. So the idea is that when you're working in a team or working on a new feature, what you would do is, it works on this concept of creating, the first step is to create an issue, which essentially refers to something that needs to be fixed. Essentially you're raising an issue in the project that a certain task needs to be done or a new feature needs to be created or something like that. The next step would be to make a new branch of this, of the original software and make your changes to it, add the new feature, whether this is in a team where you're collaborating and you make a branch, or you could, if you're contributing something more open source, you can make a fork of the repository and essentially make your changes over there. The next step is to create a pull request. The pull request is essentially, from the example, when you actually send your version of the code to the main contributor or the maintainer, and actually the person can see the changes that are being made and possibly merge them in. And with GitHub, you can actually have more of like a discussion about this before making the change, perhaps make some more changes, add more commits, and then eventually when it's approved, you can merge it all in. And finally, when it's combined, it'll be merged into the main branch, whether it's coming from another fork or from your own branch. And for this, I actually had a really nice demo, but unfortunately, it doesn't work anymore because the bot involved in it was taken offline recently. But I made like a slightly simpler version, which is not as nice, but it'll give a good example. So what we're going to do is, if you could, so first of all, does everyone here have a GitHub account? Or if not, is there someone near you, sitting near you who does? Like if you don't have a GitHub account, just raise your hand. Okay, so everyone does? Okay, great. So what I want you to do is just if you could go to this link, and also on the Slack, if you could just send your username so I can just add you as a collaborator on this repository for this demo. That would be great.
Can you post us the link on Slack?
Yeah, I'll do that. I guess I'll put it in, I don't know, questions. Put it here, maybe? Or put it in random. So I've posted the link in random on GitHub, on Slack, sorry. And if you could just post your GitHub username in the reply as a reply to this message, I'll add you in.
Does anyone need help with GitHub just enable good support? Everyone is. Yeah, if you do that, I can come.
Okay, so has everyone done it? Someone who hasn't done it so far? No? Okay. So I think you might have got an email asking you to confirm if you want to join the repository. So if you just confirm that, then you'll be able to make all the changes that are needed. In the meanwhile, I will go to the repository. And okay, so if you're ready to start, what we can do is, so the first thing we should do is, if you go to the tab up here, where it says issues, you can go here and create an issue. I can see some of you have already done it. And I don't know, let's say I go with this one. And essentially what you can do is you can go in an issue and say that, okay, yes, this is important. I don't know. And comment on it. And essentially you can discuss, essentially the issues is a place where you can discuss what changes need to be worked on and maybe even like assign someone the responsibility of it. Let's say I want to assign it to this person and this person to work on it. And so you can give it different labels and so on. And essentially what you can do is this is kind of a discussion place where you can discuss all the changes that need to be worked on. The next idea is that if you've created the issue, what I want you to do is just go over here where it says branch master and create a new branch, something that you can know that's uniquely yours, so that you can try and make a new pull request based on that. So you can create a new branch. Let's say I want to make one testing. So put testing and my name, and I've made a new branch. And essentially what I've done now is once you've created the branch, you can go to your branch, and what you need to do is go into the post folder and just create a new file here. So you can say new post and just enter some text. I don't know. You can put something interesting, funny, whatever you want to put here. essentially what we're then going to do is once you've created this new file, we're going to try and merge this in with the pull request into our main repository. So, I don't know, testing this for demo, hope it works. And essentially, what we're doing is right now we're working directly through GitHub, but all this can also be done directly in the command line on your system when you create a new file and create a commit and so on. You should. I'll just check. Yeah, you could do that as well. Yeah, if you know how to do it. Yes. You should though.
All right. Thanks. Yeah, I got it.
You did? Okay. Perfect. Okay, is anyone a bit behind that? Should I recap something, or is everyone okay?
Can you maybe zoom a bit?
Yeah, sure. And so essentially, once you've added something in the file, you can create a commit. So essentially here you just put your commit message, and you can commit it directly to the branch you just created. And so you say commit new file. And what you'll see is that you're now back on the original page, and you can see that the branch you're on is one commit ahead of the master. And what we can do is if we then go back to the master branch, we can go here. So then if we go to the pull request tab, we can see that it's telling us that we made some changes to our current branch, which we made, and we can try and merge this in with the pull request into the master branch. And so if we press here, compare and pull request, we have the option of maybe giving a bit of an explanation. So you can say that creating post for demo, I want to add these changes to show how pull requests work. And you can create a pull request this way. And what Git is doing is that it's checked and it sees there's no merge conflicts. You would have a merge conflict if suppose you tried to create a file that already exists, you try to modify that and someone else also modifies the same file, in which case GitHub would let you know that there's a merge conflict. In this case there isn't, since I created this new file right now and hopefully no one else committed there. And now we have this pull request. And as you can see, there's more pull requests here. And suppose I go to this one, I can say, okay, let's see. I can come over here and I can see what are the changes that have been made with this commit. So I can go here to files changed, and I can see there's some text here, there's a link. So I can see these changes that have been made in this file. And let's say I say that, okay, this is great. So I can maybe ask for more suggestions, in which case the person would then go back, make a new commit in which you add more to it. Or you could say that, okay, great, merging. And so essentially, at this point, you can have a bit of a discussion. This is where you would then collaborate on the changes that are being made. You can see what changes other people have worked on. And if everything is okay, you can essentially say you want to merge this pull request in. Here you have a couple of options where you can say you want to have a new commit made which is doing the merge. In this case, there are no conflicts, so it should be okay. But essentially, you can essentially combine the commits together. So it's just a bit of some features here in GitHub. But essentially, for us, it's okay to just merge it in directly. And so I can say merge it. It's creating this new commit. And okay, that should not have happened. Let's see. Okay, there we go. So essentially now the pull request has been merged successfully. And if we go to the main code base in master in the post folder, you'll see that this new file has been added, which was through the pull request. And so the idea is that since you all have collaboration, you have the rights to actually make changes here. So any of you can actually just try it here, maybe comment on someone's post, maybe try and merge a pull request. and this repository will be open, so you can even like do any testing you want here afterwards. Or if right now, either way, it's fine. Okay.
I was wondering, is there, I mean, you often get the, you do some changes and then master moves along and then you get the request to rebase. Is there a UI option for it? Because that's like the only, I had the case and then I was okay, I rebased against master, but then I need to force push to the branch because otherwise that's like the only legitimate force push I ever encountered, but is there another way to do it?
So you can do it when, so when you're actually merging the pull request, I can show
it, but if there's conflicts, the maintainer wants you to resolve, then he tells you you do the rebase.
Right, no, in that case, there's no option directly in the UI for that, unfortunately. Yeah. But yeah, so in terms of the content I had, that was it. But if anyone has any questions or anything, you can let me know. Yeah.
Maybe we could just take this.
Yeah.